Welcome, everyone. We have a fascinating and one of our first live stream pods here. And we're joined by Avery, Rushi, and Nick from Aptos, Movement, and Celestia. And I think if you've been still in crypto, haven't pivoted to AI, or haven't left, I think you've heard the word modular before by now. Hope you have. And so this is going to be a fascinating discussion because there's a lot of intersection happening between these ecosystems. And so welcome, everyone. Why don't we get started with quick intros? Avery?
Hi, folks. I'm Avery Ching. I was at Meta for 10 years before co-founding Aptos Labs with Moshake. And before that, I have a PhD in high-performance computing. I'm the CTO currently at Aptos Labs. Great to meet you all.
Rushi?
I'm Rushi, co-founder of Movement Labs. Background is engineering, system-based and database security at United Health Group, and then got into early Ethereum engineering and Aptos engineering. And here I'm at Movement.
I'm Nick. I'm the COO at Celestia Labs, and we're building the first modular data availability layer. And essentially, you can think of Celestia as this new type of layer one that is built specifically to scale L2s and rollups and enable more flexibility for developers.
That's great. Well, welcome, everyone. Again, I'm curious if any one of you guys can just broadly, simplistically kind of explain what modular blockchains do, what they uniquely enable, kind of what the problem is that you guys are solving.
Yeah, I can take that. So modular blockchains are contrasted with monolithic blockchains, and most existing sort of L1s since the birth of blockchains with Bitcoin and Ethereum have been designed in a monolithic sort of architecture where essentially the same set of nodes do all the tasks that a blockchain needs to do to provide the infrastructure to run applications. And so those tasks are consensus, data availability, and execution. And when you combine all those things into one monolithic stack, it kind of imposes some limitations on scalability as well as flexibility. So the modular blockchain thesis is that you can actually decompose these functions into separate protocols that can then be stacked on top of each other and recombined. And when you do that, you can get better scalability, you can get better flexibility, because each one of those layers can be, specialized to perform that function really, really effectively. And so, there's different layers of the stack, Celestia being sort of like a consensus and data availability layer, but then you have things like Movement who are building the execution layers that run on top of things like Celestia.
Yeah, excellent. So Rushi, maybe that's a good segue into talking about like what Movement actually is, and how you're working with like Aptos and Celestia.
Yeah, so Movement is building the first Ethereum layer 2 powered by the Move virtual machine that leverages Celestia for data availability. I think in the past, we've been using EVM for the past few years, and most developers in the ecosystem can be like, this is horrible. I'm getting hacked for $4 billion every year. And now what we're seeing with the modular thesis, and what modularity means to me, is the ability to truly build whatever. Choose whatever execution layer you want to use, choose whatever DA you want to use. It's use case specific blockchains. So whether you're building a blockchain for gaming and you need parallelized throughput, low gas fees, or you're building a DeFi specific one and you need smart contract security, so Kyber swap attack doesn't happen again, the curve attack doesn't happen again. And I think we're focused more on smart contract security, scalability, coming to Ethereum with low gas fees powered by Celestia.
Got it. And I guess you're using the Move language, which obviously you guys at Aptos have taken what was, I guess, the initial team of Facebook, then spun out, and then you guys took that. And can you just explain the novelty of Aptos and Movement as a programming language relative to Solidity? Because for context, I would say the lion's share of developers still are working with Solidity and exist in the Ethereum ecosystem. But you guys obviously came out and with Move, and so anyways, if you could explain that. But
yeah, thanks for that segue. Back in 2018, when Meta started looking at what it would mean to build out a scalable payments network that could support for billions of people around the world, we had to kind of, we were definitely inspired by what Ethereum had done, what others had done in the space, in terms of what was possible, but we realized that technology would not scale to the use cases that we wanted to design for. And so that meant a new blockchain architecture, which was DM, a new programming language, which was Move, And the idea behind Move was, how do we kind of get from ideation to production as quickly and safely as possible? And being very inspired by Rust around pushing a lot of the bugs from the runtime into compile time earlier in the programming stack. And then thinking about what are the primitives necessary to make sure money movement is as safe as possible. So it can be dropped on the floor, can be accidentally minted out of thin air, all those things as built-in ways that programmers can't hurt themselves. So just a safer way to get smart contract language development into the hands of programmers. Now, I think it's worth noting that very few smart contracts were working at a time. We were writing for very specific use cases. So things like travel rule, governance were some of the earlier primitives that we worked on in the early days. Now, fast forwarding a little bit, at Aptos, we wanted to definitely take this forward to a massive degree. And so a whole bunch of the team has come with us to make that happen. And Move at Aptos has taken on a massive pivot kind of from its original vision in terms of how do we take on, especially parallelism from programmers to extract it automatically. So with block STM technology, I think, which is being used by many other protocols in the space and being inspired by that, we kind of call that implicit parallelism. So when a programmer starts to design their contract, whenever there's parallelism possible, it'll be extracted automatically from the program without having to impose any necessary boundaries on them. Also, when you think about programs, they naturally touch different pieces of shared data, and being allowed that shared data to be kind of in the same program as opposed to being split across programs to extract parallelism, which is what happens with a lot of other programming paradigms, produces a lot of challenges. And so I think that's some of the core things that we have really been taking forward in the language. Also, formal specification and verification is really important to us. So the Move Prover code has been an amazing asset for making sure programs are safe running in the Move space. The entire framework at Aptos is actually formally verified, which is really, really incredible as a particular tool. And so, there are other Move variants out there, just again, being very transparent. There's the original kind of DM Move that was there. There's the SWE Move. And I think Aptos is kind of the most fully featured superset of these different moves out there, and the most supported, and the easiest for integration into different platforms. And I think that's kind of why we're excited about Movement being one of the many different kind of providers that are taking Move into different ecosystems going forward into the future.
Yeah. And so maybe if you can, Rushi or Avery, if you want to take this, but unpack like from a developer experience, how is it, if you're trying to convince someone that perhaps is coming new to crypto and wants to build an application, how would you frame it to them? It's here's why you should build on Move. Here's why you should utilize Movement. And how would you kind of frame it and pitch it to them? Because the natural perhaps inclination still may be, I want to build where the users are and the liquidity is today, which in my opinion is sort of like we're all beta testers, and it's not really going to, like, we need to think about at scale, like where are most users going to exist and build towards that. But that's just my bias. So if you guys could just comment on that.
I think an analogy I use is Move is to Rust as React is to JavaScript, in that it's a very specialized version of programming. Rust has been around for years. It's a standard now in multiple industries. I believe Microsoft is now using for AI. Biotech is huge. It's clear that Rust is like a very hot programming language that's very powerful. And what Avery and a few other great guys really did, and girls, is made Move the programming, like Rust made Move the blockchain programming language powered by Rust-based provers, Rust-based mechanisms. And the way we kind of approach it is like Avery and Aptos doing a phenomenal job at innovating the Move language, some of the best engineering work I've ever witnessed. We're approaching it as like a very Web3 focused angle. We acknowledge that in the short to mid-term, Solidity is still going to have mind share. It's going to be difficult to get EVM adoption away, especially when liquidity lives on the EVM, all the developers on Solidity. In a bear market, if you're going to developer and say, hey, learn this new language, it's probably going to be a very tough battle to win, which is why we kind of explore this idea of a transpiler, which allows any EVM code to launch, things Solidity code, Curve contracts, Aave contracts, Uniswap contracts, can seamlessly deploy on our SDK. It'll transpile down a Move bytecode and launch the VM itself. So we kind of hedge our bets in the short term where we're saying, okay, we believe in Move as Thesis. We believe the future of programming is Move. But in the short term, we acknowledge that Solidity has a lion's share of developers. So we allow seamless deployments to Ethereum JSON RPC, MetaMask compatibility, hard hat compatibility. That all comes out of the box. And any Solidity code can now run the great Aptos DM VM or Move VM and live on Ethereum. So you get the liquidity of Ethereum. You get the benefits of EVM tooling and development, while still harnessing the benefits of Aptos and Move.
So this is really this bridge is so if you're a project that is already built on Aptos or perhaps Sui, some other, you allow it just to seamlessly like deploy and run an EVM instance on Movement and like attract all the users and the liquidity that may exist. Is the end goal to ultimately just like bring it all back to something like Aptos, where once people realize that it's just better? I'm curious how you think about like, because the analogy, once you see it, like you don't unsee it. And so once you start interacting like in a move based, like for the user, it's like, well, you don't have a reentrancy attack. And so DeFi becomes a safer environment. And so how do you think about like that user flow, perhaps in the next, 1, 3, 5 years of the state of Aptos and Movement relative to Ethereum and the growth of like liquidity users?
I can take this one. I mean, I think the goal would be that as it's a technology argument, right? You brought up a lot of advantages of what EVM has today, definitely users, developers. But as what we've seen and observed from people building on Move with Aptos is that people who start writing this code just love it. They don't want to go back. And we've seen flagship projects, from the EVM world come over to Aptos using Move and being really, really excited about that, whether it's SushiSwap or it's a live here, and many others actually coming in haven't announced yet, but are be moving over, no pun intended, in the coming months. And as people start to see, like again, the idea from ideation to production as safely as possible, and these reentry attacks are not possible. You have the additional safeness of formal verification in the place, and also you have this very rich way to get parallelism, kind of both optimistically as well as pessimistically coming in the future. And then seeing the way that we evolve the language, the V compiler and the VM, we have a very long roadmap of like taking it to the next level. I think that is going to be the reason why people start to use these different networks that are Move compatible. So whether it's going to be Movement chains or what's happening on top of Celestia, we want Move to be the interface into how all the smart contract programming happens in the future.
Mm-hmm. Nick, I want to go to you and Rushi as well, commenting on how important was it to like this data availability, like unbundling for you guys, where you can now use Celestia from a cost perspective. Like, what does it mean to be able to utilize Celestia versus do DA and consensus in-house? And I'm curious if you could put a finer point on the benefits of using something like Celestia.
Yeah, I'll start off, and then I'd love for Rushi to jump in too. So there's a lot of advantages to building on a modular stack and a modular foundation like Celestia. So one of the key things, right, if we go back to modularity, is decoupling execution from consensus and data availability. So what that means is, like, when you launch a normal monolithic chain, it comes with the execution environment already defined in it. So you as a developer, when you're building on that L1, are stuck with that execution environment. So it could be EVM, it could be Solana VM, or it could be Move, right? And kind of like Celestia's thesis, or the modular thesis, is captured in the phrase that Rushi said earlier, is build whatever, which is that we want to remove constraints from developers and enable people to choose whatever things best suit their use case, right? And we firmly believe that there is no one stack to rule them all. Like this, like monolithic architectures tend to breed sort of maximalism, right? Because you have to say that, like, well, you have to justify that you're the best, you're better than everyone else, right? And in the modular world, it's like, well, there isn't actually a best, stack. And instead it's like, well, what are you trying to build? And then from there, work backwards and say, like, okay, well, in that case, EVM might be the best for you, or maybe it's Cosmos SDK, or maybe it's Move. And so first and foremost, I think that's one of the benefits of building on something like Celestia, is that it removes any like lock-in, I guess, into our particular ecosystem or stack. And so one of the things that we're really excited about is supporting all these different execution environments, and we like all of them. It's like a pluralistic view, right? So recently there's also Eclipse is launching a Solana virtual machine roll up on top of Celestia, and now with Movement, like, it's another offering that can kind of be built on Celestia. And like long term, the way we see things playing out is that it will be as easy for developers to deploy a new execution layer, a new blockchain, as it is right now to deploy a smart contract. So like in the long term, it will be this really easy out of the box experience to just like spin up a Move VM chain and be off to the races building whatever applications you want. And that's like the future that we want to get to. But Rushi, why don't you add your perspective?
Yeah, I think Avery touched on this earlier, but one of the benefits of Move is the parallel runtime, in that you have local fee markets. I've been using Arbitrum for a while now, and every time the GMX goes crazy, the gas fees go through the roof. So I think one of the benefits of next-gen VMs, whether it's Solana VM, Move VM, Fuel guys are doing a great job with Sway, is really allowing gas fees to be controlled and minimized. So when we're looking at architecturally building on Ethereum, sure, Ethereum is a great settlement layer. You have a lot of liquidity. It's great for mindshare and just generally good for DeFi. But if your gas fees are going to be through the roof, it creates a really poor user experience. So when we're looking at different DA layers and studying the modularity thesis, what struck out to me is, look, if I'm going to be bringing this next-gen VM to Ethereum, it can't use Ethereum's main DA as its DA layer until Pro-Dang sharding, which is years out. It needs a different solution. So that's why the Celestia research, the Celestia integration made a lot of sense, because now we can essentially bring an Ethereum scaling solution, bring a better next-gen VM to Ethereum settlement, and not have to worry about DA being a bottleneck. Instead, it can be a fraction of the cost, basically mimic some of the cheapest, if not the cheapest rollup on Ethereum. So that enables a lot of use cases for DeFi, where you kind of abstract away any gas spikes, but also on the consumer gaming angle, right? We work with a lot of gaming clients that can't afford $10 per transaction where you're minting millions of NFTs, killing 1,000 zombies. That would probably run the player like out of all their money, especially if it's like a 14-year-old kid. So having alternative DA layers like Celestia make a lot of sense to us.
Yeah. For me, some of the big aha moment, and I think a lot of the market is kind of coming to this realization is, like there are incredible benefits to this next gen kind of movement, like building an Aptos, like parallel execution and like dynamic fee markets, like just make a lot of sense when you start thinking about all the different use cases, like that are now uniquely powered by that. And I think you know, I want to get into discussion around modular, integrated, however you want to use it, versus modular versus integrated / monolithic. And like particularly in the context of like, why do you still like, what do you think is the benefit to monolithic blockchains today? Like, because one could argue, well, there's all the incredible benefit with modular, and modularity makes a lot of sense. Like the software, like pre bubble crash 99, and then software as a service. Like I kind of liken it to that. Like there's this huge unbundling, and in technology movements, the unbundling like creates a lot of new possibilities. But I think we're seeing that with blockchains, execution environments. And so I'm curious, like how you guys think about that debate of modular versus monolithic, and if there's merits to still looking at a monolithic integrated blockchain saying, yeah, I want to build there, versus the modular approach.
Yeah, I'd be happy to take this one. First of all, definitely respect the work that those in the modular space like Nick are doing. I think it's an interesting design exploration. For me, a couple things like I think look at two examples I'll pick on. One is I think the Linux kernel is a great example of a monolithic kernel, where Linus Torvald had a very strong opinion that that monolithic kernel would actually allow them to move faster and be more performant. And I think it's done extremely well in terms of achieving those goals and being deployed to pretty much all major clusters and cloud centers today, compared to modular kernels or microkernels. And I think another example was even from our early days within Meta, when we started to build out the Libra blockchain, we actually tried to build it as a microservices architecture to some degree, all connected through gRPC. And we quickly realized that this wasn't a good approach due to it was super inefficient. In theory, these things all sound great. Like I can deploy this component here, and we end up rewriting the whole thing as instead as just more like internal APIs, and the whole system got much more efficient, much faster to develop. I think it comes down to a thesis around if you believe strongly in you have a strong the right path forward, you have the right interfaces, the language is the way that it should be, the way that the system interfaces with it is kind of built really well for it. Or if you feel like there's a lot of like use cases that are not going to be covered by these particular components, then sure, adding all the optionality makes sense. And it doesn't mean you can't be more modular in the future when it comes to APIs and interfaces. You can always add those in as you kind of discover the right points for those. But today, we haven't had any concerns where people are like, well, we love Move for this, but we really wish we had EVM for that. Or we love, the way the blockchain works today, but we wish the consensus protocol was slightly different. So far, we have, every use case that we've seen being thrown in Aptos has worked really, really well. And so there's just no need to kind of explore, the alternatives right at this second that could change, of course, in the future. And the other thing I would just kind of point a point on modularity is Aptos is a modular stack. We're kind of designed as several phases. We have data dissemination, we have ordering, we have parallel execution, parallel writes, and then kind of proof verification after that. And so like you have the modularity as a design choice, and we can actually take a lot of benefits from like upgrading individual components of that and testing individual components. But one of the downsides, if you start to also get too modular in certain services, for example, that testing becomes very complex. Like suppose you want to test interaction of chain A with chain B, and chain A is changing this thing and chain B is changing that thing. If you want to test holistically, it gets very challenging. Like the number of combinations explodes exponentially. And that's something we don't think that right now we haven't seen use cases for that. Our developers are really happy with what we offer them. And, building that full stack is just simpler and more performant for us, and optimizing for it are currently today.
Yeah. We don't have someone from Solana here, but perhaps I may take that. I'll attempt to do that. But the argument would be, look, Solana just makes a very clear trade-off that they're just going to accept higher hardware costs and requirements and try to optimize the bandwidth. Like, because when I think of like blockchains, like you have the hardware costs, you have bandwidth and storage. And those are, in my mind, the three biggest categories that Ethereum guys say, well, our hardware costs are not 3,000, they're 200, and anyone can run a node, and that's great. When you actually look at the data, they're actually the same. When you look at the Nakamoto coefficients, Solana actually has way higher than Solana. So in practice, like these things also manifest themselves in different ways. But someone in my Solana would say, well, why not just come and build in Solana? Like, why do I have to go to Aptos, or why do I have to use like a modular design when, like you still need to run, like you still depend on full nodes, and running a full node has a real meaningful cost. And if you just accept that, then we can just focus on solving like hardware costs can come down over time, or solving on bandwidth, or optimizing these things. But I'm just kind of curious, like taking the camp of you could build in Solana, like what would you say to a builder? There's a lot of excitement, of course, now in Solana for a variety of reasons, but what is that trade-off between, Aptos or, Movement? Yeah.
Yeah, I'm happy to answer that question about Solana. I mean, I think Solana is definitely one of the first in the space around high performance blockchains. Obviously we're in the same field. We've taken different design trade-offs. We think our design is much more scalable from a throughput perspective, and there's different goals around latency, right? So I think they talk a lot about the block times, but finality time is actually quite different than block time, and so finality time in Aptos is generally about a second or so, and that's kind of where all validators agree on the execution of the transaction from a Byzantine fault tolerant perspective, 2/3. So I think from a throughput, and a latency perspective, you can try out Aptos. You can see the numbers we put out. We have put out verifiable numbers even in a benchmark in March, for anyone can rerun the same experiment we ran and get the same numbers of. I think our experiment showed about 20,000 transactions per second in a mainnet-like setup, end-to-end results for that. And we also have new numbers that'll be coming out fairly soon that'll even blow those numbers away. And so again, our goal is to keep pushing on the spectrum of parallelism, latency, and other aspects. And yes, so if we're not trying to support all the use cases out there. It's really about high throughput, low latency, highly safe and available use cases, and kind of enterprise grade technology that you can trust to build on for billions of people.
Yeah. Nick or Rushi, I'm curious, when you think about the projects that have become interested in working with Celestia and also using Move as a programming language, what kind of use cases and projects have you been getting the most amount of interest from?
Yeah, well, there's a lot to talk about in the monolithic versus modular debate, which maybe we can revisit. But in terms of
We can keep
adoption,
going. We
yeah.
I still
Well,
didn't want to make the transition. I think it's super. It's probably the most important discussion that we can have, like in crypto today, realistically. But
yeah. Well, I mean, okay. So first of all, it's clear, I think, from everyone that we're entering into a multi-chain world, right? Like even if each of those chains is monolithic, we're entering a world where there's going to be lots and lots of different experimentation of execution environments and a lot of different chains kind of living side by side with their own ecosystems. And I think when you like start to play that out further, the modular approach makes more and more sense in the sense that you can sort of still share security via having this common consensus and data availability layer while still experimenting with all these different chains and execution environments. And like all the optimizations that are happening in the Move world or the Solana virtual machine world that speed things up and make them faster, et cetera, like are absolutely really crucial, but they're only really scaling like the execution aspect and not so much specifically the other major bottleneck to scaling blockchains, which is data availability. And so I think that's one of the key differences. And like I would say another thing that's really important, at least in the modular space, that I think it doesn't kind of gets lost in this debate is the emphasis on verifiability too, right? So like increasing the throughput of your chain simply by requiring higher bandwidth and higher like execution, like sort of like CPU or whatever, like computational resources in the node is not really scaling the blockchain because you're increasing the cost to run a node and making it less and less accessible for the average person. So the only solutions that I think actually scale blockchains is a combination of data availability sampling and rollups. And what they allow you to do is they allow someone to verify the chain very efficiently with low resources. So even as the amount of data in the block grows, you don't have to do more work to verify the chain. Even as the number of transactions that are processed grows, you don't have to do more work to verify that execution. And so what that means is we can preserve the core value proposition of blockchains, which is end users can verify the chain and audit it and uphold the rules of the chain and not have to delegate trust to validators or other people running full nodes on their behalf. And so I think that's a really core thing that like, and I think that we need to like keep that very central because it's the core value proposition of blockchains. And I think the modular stack kind of stands for that. Obviously, a monolithic chain can implement data availability sampling and can implement these proof systems that are like rollups. But then when you enter in that world, modularity makes more and more sense because data availability makes sense to pool resources because you get all these benefits of scale, and rollups naturally lend themselves to these like just spin up your own chain. So like to me, all roads kind of lead to modularity one way or another.
can you go a little bit deeper into this specialization and like by specialization, you have all these advantages? Like what is uniquely enabled when you kind of outsource it to Celestia, when you outsource DA and consensus to Celestia? Like how does this actually like scale? And would love to
Yeah,
unpack that.
so Celestia is the first L1 that was designed for people to just only run L2s. And so you could, for example, run a rollup on Solana or Ethereum or all these things, but it ends up being very hacky because those L1s were never actually designed specifically for that use case, right? So like even the way that rollups run on Ethereum today is by using call data, which was, I don't think it was like ever planned that like, oh, people are going to want to run these rollups, and then therefore we'll design this call data interface as a way that's optimal for that. Versus Celestia was like designed from the ground up for this use case. So there's a bunch of things. First is that we scale specifically data availability via data availability sampling, which means that we can scale the block size with the number of sampling nodes in the network. And so no other blockchain has this property where you can increase the throughput without increasing the node requirements. It's just, you just need more people participating. And I think that's a huge unlock. And that enables us, for example, to have these extremely low fees for L2s, and why you would launch, for example, Movement is launching using Celestia rather than Ethereum DA, for example. In addition to that, there are
And
things
just
like
to put it in perspective, that's a order of magnitude save.
probably multiple orders of magnitude.
Multiple
I think,
orders
compared
of
to ETH DA. Yeah.
But like even
I
compared
think-
to like if you're a normal L2 launching on the OP stack, whatever, and you're not using Celestia, and if you use Celestia, like that cost save translates into one or a couple orders of magnitude.
I think we're still working on exact numbers, and we'll have that more concretely when some of the first rollups launch on Celestia. But I think it'll be multiple orders of magnitude. And so, because the main cost driver for rollups, especially optimistic rollups, is not the settlement cost, but the DA costs. And so when you can offload the DA cost to Celestia, it dramatically reduces the end user costs. But anyway, just back on the specialization point, some other things that Celestia were designed for is like it's overhead minimized, meaning that so when you're running a rollup on top of, let's say, Ethereum or any other L1, you have to verify what's actually happening on the L1 too. So you kind of have to run like a full node of that L1. And if there's a lot of execution and state and things to track on that L1, then that adds overhead to every single rollup that's running on top. So Celestia is designed in a way where it has basically no execution, has a minimal amount of execution and minimal amount of state. And so like verifying Celestia is as light as possible. So all the rollups that are built on top don't inherit all this like baggage and overhead that you would, for example, if you're running on Ethereum or other like monolithic L1s. So, and then also like there's things about it's designed specifically to post data to it. So like the interface for posting data is very clean, and the way you pay for that is all like optimized for that use case. And that's just something that a monolithic L1 can't do or could, but it has to like completely start from scratch.
Yeah. Can we comment on like around this like throughput? And I'm not a TPS maximalist, but yeah, like if we just compare TPS as a figure of like all these different use cases that can be enabled, right? If you're going to Visa, well, they care about TPS, I guess, and of course other components. But one could argue like, and I'm referencing some figures here, but like Solana, for instance, with FireDancer has, I would say like probably the highest TPS. And then you go down from there, like with Celestia, like what are the improvements? I guess I'm curious, like movement, like where does Aptos stand in that spectrum relative to Ethereum, relative to Solana, and where does like a movement VM with Celestia stand in that spectrum? And I'm not saying TPS is the most important thing, but I do think it's important to just like call it out, I guess.
Yeah, I think by the way, TPS is a metric that has to go away at some point. I just want to be very clear. Like it's a really poor way to like.
That's Avery's fine way of saying it was a very stupid question, but anyway.
No. I think, by the way, it's a very fair question. Everyone asks this all the time. What is the transaction throughput of your system? The issue with TPS is that it really depends on the transaction types that are being issued, right? And that's why databases have TBC benchmarks. So you can actually test out a suite of different types of operations and understand for this type of workload, this is the performance you're going to get. For this type of workload, this is the performance you're going to get. And in our world, unfortunately, there just isn't standards out there. We've done our best to try to put out some standards. Again, we've put out repeatable benchmarks. We'd love others to do the same in this space. So, have a Medium post that describes like, here's our exact setup for how we ran our experiment. Here's the exact types of transactions we've run. We have coming again very, very soon, a improvement upon that where we'll describe different types of workloads that we think are important for different kind of crypto use cases. And we'd love others to go ahead and participate and share, what they think is important, and also ideally adopt some of those benchmarks that we put out there, so we can have an apples to apples comparison instead of apples to oranges to bananas to pears to whatever, jackfruit, thing that's out there. And so, I think FireDancer, is probably is an interesting product. It is something though that is kind of still designed within the current Solana parameters. It's just a faster implementation of it, and so. Today, I don't know if we've actually seen any verifiable numbers from what Solana can do in an actually controlled mainnet type environment. And so I think, these are not apples to apples numbers that we compare. And the only numbers that we know of, that are kind of show the benchmarks from the space are the ones that we put out there. So again, as of now, we think that we've shown the fastest numbers in transaction throughput. They are verifiable, they're repeatable. You can run them on the same GCP hardware. You'll actually get better numbers today. We haven't shared those yet. We will share those in the coming weeks. But you'll get, the same kind of results that we have at this particular time. And I think they're the only ones that are verified for now.
Yeah. I guess the better way to reframe the question for all of you guys is like, when you think about scalability, like what is exciting now is that there are many different use cases that have been tried in the past, didn't work. We're in a different environment now because, with Celestia, we're in a different environment because of Aptos, and then with the movement VM. And so I am curious, when you think about like scalability, something that, to your point, Avery, is heavily discussed. It can mean a whole variety of things. It may be the most important thing for certain, but it just depends on the use case. And again, there's trade-offs and whatnot. So it's a very nuanced discussion, and I don't think we have enough time to do it. But I do think the more exciting thing, maybe transitioning a bit into the discussion, is like, Rushi, like, as you guys have set out to do this kind of connectivity between Ethereum and those, and I'm curious, like, what type of use cases do you envision? What type of projects do you envision building and utilizing kind of this bridge, for lack of a better term, or just environment that kind of gets the best of both worlds?
I think what gets lost in like the infrastructure discussion and like the whole modular versus monolithic discussion is like, what do the builders actually think, right? So me and my co-founder were just dApp builders. I was a DEX builder at Aptos. My co-founder built the first yield aggregator at Aptos. So we're really looking at it from like, how can we build better financial products for our customers? It didn't really matter to us what the TPS was, because if we got 5 TPS, we were throwing a party. It didn't really matter much on like what latency was at that point, because we were just trying to figure out like, how do we get 10 users on our app? I think what kind of led us to the modularity thesis is that we could permissionlessly innovate, if that makes sense. For example, when we were building yield aggregator, there's only 3 assets that we had at the time on testnet. It was like the APT native token and like 2 live native tokens, and that was on testnet. So we're trying to get customers to use our app. It was like, do you guys really want to play around with 3 tokens that like not that many people know about? Or do you want to use native ETH on your protocol? Do you want to use BTCB, which is powered by the Snowman consensus that we leverage? Do you want to use EVM assets, which are usually more speculated upon? So we're taking like a DeFi app to mean that, think about DYDX, perps, lending. It's usually the EVM assets that are usually speculated upon that drive demand to your protocol. So that was the bottleneck that we face as builders in the space, which is often forgotten in these discussions. And I really haven't seen it come up. Like, cool, latency is cool, like the fees are like cool, but most of that's in theory. What we're looking at infrastructure today is, I want to build a DEX in the next 6 months. If I'm going to monolithic chains right now, especially ones that are starting up, on the come up, usually these assets aren't speculated upon heavily, and it takes time for development to occur. It takes time for stable coins to come. It takes time for bridging to happen. Whereas when we went to a modular chain on top of Ethereum with Celestia, we built a Hyperlane bridge in a month, right? So now we have full connectivity with the rest of the modular ecosystem, with other EVM chains, and we didn't have to wait for a third party like Layer 0 to Wormhole to prioritize us. Instead, we could just do it ourselves. That ties in IBC. We were able to fully bring IBC to Move, which is pretty exciting. And also like assets, right? So when we have DeFi apps that build on top of a chain, now you have Aptos and Sweet assets, which are Move assets. We can also have native EVM assets. So native ETH in your protocol, BTCB in your protocol, Lido in your protocol, native Ethereum assets, which can actually drive adoption for these Move protocols, and make my life as a builder a lot easier. But I'm sure Nick has more thoughts on like modularity in that sense.
Well, I think you hit the nail on the head in terms of like permissionless innovation. I think that's a big part of the modular thesis, is this idea of like, just set the developers and the builders free, and give them as many options as they could want, and then let them build whatever, essentially. And I think it's really, I'm glad to hear that that's like one of the things that it does end up mattering to builders like Rushi. And I think just on the throughput conversation earlier, I totally agree. I think transaction per second is like a bad metric for all the reasons that Avery mentioned. And at least for us, and what I think will eventually become like kind of the standard, at least for the base layer, like data availability stack, is just simply data availability throughput as a metric. And that is universal, because you don't have these things about like, oh, well, what kind of transactions are there? It's just like, how many bytes can you publish and make available on this L1? And I think that's something that it's great. It's another benefit of this modular paradigm, is that it really clarifies. It's like, okay, we know what the objective of this protocol is, or like what are some of the things we need to maximize, right? And one of them is just data availability throughput. Now, with the constraint of it must be actually easy to verify and all those other things that I mentioned earlier. But I think that to me is a very clear standard that I think will emerge, is like what's the data throughput of your chain?
Another builder thing, then Avery can go, is why it drew me to Move is the concept of velocity of production. I think I was an EVM builder before that. And for me to build a Solidity dApp as like Dex or Yield Dagger, it took me months. And I've spent another few months auditing the code and then pay $100,000 to an auditor who would audit the code, and then it still will probably get hacked, right? So that was a whole headache for me. And then when I stumbled across Move and the work that Avery's done, it's like, okay, so like 90% of the hacker attacks that I was spending like countless hours at 3 a.m. like are kind of taken care of for me. I don't have to pay this auditor $100,000 to like, not do that great of a job and still get hacked. So we focus on velocity of production. If you're a random developer, think of Mark Zuckerberg in his college dorm, you should be able to ship mainnet code as quickly as possible, not worrying about security, instead of worrying about actual functionality. Build the best SocialFi app. Don't worry about that 108th line of the code that you glossed over that can lose your protocol 3 million and lose all your credibility. That's the biggest issue in development as a young and aspiring being infrastructure and application developer. It is too difficult to build the killer app. We're making the killer app easier with Move.
Yeah, I couldn't agree more with that. And I don't get me wrong, I really love the fact that like Movement and Celestia are partnering together to make this happen. I know, Nick, you're putting your bets on all these different, ways of languages, or whether it's Solana VM or EVM. But I think hopefully the right stack will emerge over time, and maybe they'll be less focused on the ones that are not as interesting to your developers as that plays out.
Yeah, I'm curious, like just looking ahead, like the synergies between the teams, and also just how do you think about, all this is fairly new. How do you envision the next, I don't want to call it the next cycle, but just like the next 2-3 years in terms of just developer interest, activity, type of applications with all this kind of new possibilities out there?
I'll go quickly. I think the EVM burns. I think every developer is sick of the EVM. Like there's literally a major hacker attack every year, every month. It's the same re-entry bug over and over and over again. It's like getting punched by the same kid over and over again, and you're not doing anything about it. So hopefully in the next 2 to 3 years, we see more adoption, get the blue chip DeFi protocols actually on Move, some other networks, just anything besides the EVM, and I'm happy.
I completely agree with that. I mean, I think the technology space is going to evolve rapidly. Like I said, we were doing 20,000 transactions in a verified environment that anyone could rerun in March. That number is going to increase significantly in the coming weeks as we put those numbers out. And in next year, those numbers will increase even further. And so as we see the technology start to grow to really rival those of traditional databases or other systems that are used for money movement, it's going to be a pretty massive technology advantage to move more into the blockchain space. And we're taking a very opinionated approach that our version of Move is going to be the dApps version of Move is going to be the one that drives this innovation forward, with new compiler coming out, with new VM technology coming out, with folks like Rushi and others helping us to derive this from a developer standpoint going forward, as well as the system, being co-designed with it. Like hardware software design is something really important. We think about full optimization across the stack. And as Nick pointed out, these metrics around like whether it's going to be data movement or I like to think about resource usage. I worked in distributed scheduling for a long time across 100,000 machines. How do we measure the real performance usage and benefit from these different infrastructures will become very, very clear, and massive adoption in the coming years, because these big enterprises and other large applications will be very confident to put their use cases on top of blockchain, because it's truly scalable, it's truly reliable, it's easy to build on, and the user pain points around how the user experience of onboarding is going to be much simpler when you have things like account abstraction built directly into things like Aptos Move, as well as I'm sure Movement, what they were doing as well.
Yeah, I agree that the EVM is not the be all and end all. I think a lot of people over-index on that. I think it just had the first mover advantage, but there's just, part of the modular thesis, again, is experimentation, and especially experimentation at the execution layer has been held back by the fact that to try out like a new execution environment, you had to launch a whole new L1. And now when we remove that barrier, we're going to accelerate the velocity of innovation at the execution layer. And that even includes like new flavors of the EVM. Like we have teams like Manta Pacific who have built an EVM that has like ZK opcodes inside of it. And so I'm really excited for that, like just unleashing a whole new wave of innovation at the execution layer itself. And I think in the future, what I see is just, right now L2 Beat has something like 30 rollups or L2s listed on it. I think in 2024 into 2025, we're going to have thousands, maybe tens of thousands of rollups eventually. It's just going to be like smart contracts. It's going to be the same thing as we had kind of in the wave when Ethereum first shipped, of all these people just like deploying new apps. I think we're going to see something similar. And and it's going to also have this explosion of all these different combinations of different components, modular components that you can mix and match and achieve different trade-offs. And so I'm just excited for experimentation, because wherever there's experimentation, there's innovation, and there's going to be a net new applications and use cases that haven't existed before. So the whole space can move forward. And I'm just stoked to see what comes out of it. I can't predict what will be the breakout use cases, but I'm sure that we'll find some.
Yeah, I don't think anyone envisioned Uber when the smartphone came out. But I am, as a general point of just curiosity for me, is in this decoupling, unbundling between execution, settlement, and DA consensus, and kind of like this Rubik's cube analogy. Like, where are we in the state of like integration when you do that? You talk about IBC, like connecting all these different chains, but like, can one of you guys just simplistically comment on like how these, like, when you do this unbundling, are you losing some sort of communication or performance by doing this unbundling, or not? And I'm just curious.
I think I'd be the first to say that like it's gonna, integrated chains have an advantage in the sense of, if you already define how all the pieces fit together and you've tested them, et cetera, like what Avery is saying, like it's going to work out of the box. And I think, one of the near-term challenges for the modular space is going to be defining those interfaces in a way that makes it actually like more pluggable, and then also making it easy to test all these things. So I will be the first to say that I think there will be challenges to it, but like there's a lot. The good thing on the flip side is that there's all these different teams that are incentivized to make this work. And so there's just a huge amount of really talented people tackling these problems. And you have teams like roll up as a service projects who are sort of like system integrators who are like, okay, here are all the components, and we're going to plug them all together into this stack and like sort of sell that as like an end product to people who want to deploy a chain. And so like you have people from across the modular ecosystem that are like actively really working on this. I think we're going to still struggle for a while to have better bridging. I think that's just not solved. Like that problem exists like everywhere, not just in the modular space, but any cross-chain thing is still not quite as smooth as I think it could be. And that does diminish the value proposition of everyone launching their own chain, because then you are, until bridging becomes more seamless, yeah, it will be a little bit more fragmented and composable. But I operate under the assumption that, or the belief that in the long-term future, cross-chain composability will be really seamless. And so like eventually we'll get there, but for the near term, I could see an advantage to sort of like a shared execution layers, like Solana or Aptos, or even like, Arbitrum, for example, as a roll-up example, where, it makes sense for people to build there, because like you do get this seamless composability that might still be a challenge for like cross L2 stuff.
Yeah, I think
Go ahead, Rushi.
I think it's largely use case dependent. At the current state, like if you're trying to build a Venmo for crypto, I would argue it's better than Solana, Aptos, Sui. It just makes the most sense. It's easiest to do out of the box. I think if you're trying to unlock different use cases that weren't possible in monolithic chains, like I touched on, like innovative DeFi apps that can use assets from different chains, like IBC enablement, stuff like that. That's where modular chains have an edge, because you can kind of customize it. You don't need to wait for a third party to add dependencies, add features. You can kind of innovate by yourself. If you're just looking to use blockchain in the background, build a payments app, build a gaming app, and get to market as quickly as possible, in the current state, I would say that monolithic chains will win. So I think it's monolithic and modular in the current environment, not or.
Would you, Avery, Nick, would you agree
Yeah,
with that?
I mean, I think, I think they're just different exploration spaces. And like I said, I respect the fact that people are exploring different ideas. And I think you can probably innovate faster in a monolithic chain a modular chain, as Rushi suggested. Our goal is always to support the 99% of use cases in Aptos, and there might be 1% we don't hit, but we haven't seen it yet. So we would love to wait until kind of. What I've learned as a developer for a long time, though, is it's really, really hard to build APIs before you know the use cases, and you almost always get it wrong, and that's the problem. And Nick alluded to this earlier, right? It's tough because you don't know what you want until you have a use case that you're driving it, and then like exactly what you need in those APIs to push forward on. So we're always open to adding APIs at the right layers and allowing people to plug in and play different things. But we kind of wait for those use cases to emerge first rather than being a little bit more proactive about it. That way allows us to focus on our core stack, support those, pretty much most of the use, if not all the use cases out there we've seen, and then builds in a simpler and easier to test and more performant from the get-go.
Yeah. If you were to predict, like, what is the killer use case that's going to emerge? Like, obviously in the last cycle, a lot of it was just innovations in DeFi and DeFi summer and yield farming, which was fun until it wasn't. What do you think is the next catalyst and like the first type of application that just gets mass adoption?
This is a hard one. You want to go ahead, Nick? You can go first.
I don't have. I feel like it's one of those things where it's very hard to predict because, and if you could, maybe you would go out and like build that, right? So I don't know. I don't have a good answer. I think that some things that I think are kind of exciting are things like on-chain gaming. I feel like gaming is something that naturally has this like virality and mass market appeal. And if you bake in the right kind of like economics or incentives, it could really like take off. And I think also things like social-fi applications similarly have this baked in kind of like mass market and like if you crack the incentive code could like spread virally. So I think about those things. I think stable coins are something that already have like really strong product market fit. And so there could be something around payments or just leveraging like stable coins that could also really, really take off. And those are just some ideas off the top of my head. But I think universally, I'll just say that all those, in order to reach mass adoption or like these breakout use cases, you need to have the underlying infrastructure ready to absorb all that demand. And so that's why it's so important that like teams like Aptos or like Celestia, et cetera, are like trying to build this like underlying capacity to like, so if we do hit that hyper growth as an industry, we don't just scale fail and like go back.
We're not in dial-up, we're broadband. We need to get to broadband.
Yes.
That's right. I think those are all great use cases that Nick laid out. The one I think that is hopefully coming a little bit sooner than later, and maybe it's more of a hope than a reality, is really about how blockchain can provide much more accountability and responsibility to AI innovation going forward. And we've been working very closely with Microsoft on a couple of different initiatives in this space to understand how does identity play into the picture? How do we get responsible AI where if you're using if people are using your data for training, you're either like giving your explicit permission for it, you're getting compensated for it, or other or you're just not giving that permission at all, right? And so those kind of things are very interesting. Also, like verification of content of AI, right? So if someone posts a video of Rushi dancing on a tree, like Rushi can say like this was really me, or this was like someone faking that content. This is not me.
Your private keys are proof of humanity, I guess.
Yeah, proof of humanity is a really important thing that blockchain can do as a auditability with private keys and user signing to show that kind of attestation of whatever content's being put out there in market. So that's an area that we're pushing very hard with a couple of partners on, and we really want to see that change happen in the world sooner rather than later.
Rushi, what's going to be the killer app in MoveVM?
I think payments outside of infrastructure is just like where the obvious use case is. Sending money from like Thailand to like Ethiopia in under like a second without using like Western Union, without having to pay PayPal like 30%, and having like centralized authorities. We're still waiting for the Venmo crypto to come out, but I think that's what gets me personally excited. Whether it's on Aptos, whether it's on Rollup, it doesn't really matter. Getting the average user to use USDC in a backend, not mention blockchain once, is what kind of keeps me going. How it's accomplished, I don't know. I don't know what chain it's on. Don't know what wallet it's on. But the team that does that and gets people actually using blockchains for payments and USDC everywhere in the back end wins.
That's fair. Maybe as a parting question, I'd like to get two components, but the first question really is, whenever there's an unbundling, decoupling, over time there tends to go back to bundling. Like you see these unbundling and bundling waves in technology cycles. As you think about, we're, I think, now entering a phase of mass experimentation, right? Because you all of a sudden can decouple them, and we're going to try all the different flavors, SVM, MovieM, and all the different components. Do you see a time where we ossify into one standard of the stack that is the most optimal, or do we never get there? Like, will we define like 1, 2, or 3 very nicely like stacks, or it will just be like there's going to be so many different verticals and use cases that we never kind of like define a standard in this modular movement, and you just continue to iterate and innovate?
That's a good question. The way that I see it is not so much in like the rebundling, that's not the way I would frame it, but like consolidation, definitely. I think like, you have this exploration divergence, and then like there's like kind of clear winners that kind of like emerge, and they become like sort of network effects around certain execution environments and what have you. So I do expect that to happen. And there might be sort of like a power law distribution of like, here's like the most common execution environment that everyone uses, and then it kind of goes down and there's like a long tail. But I think there will always be a long tail, and we should enable that long tail for sure. And one way, like I often use a sort of analogy. The way that I think about modular blockchains is very similar to like cloud infrastructure, and that like a rollup is like sort of like a virtual machine that you deploy on like a data center, but instead of a data center, it's a data network like Celestia. And the cool thing is, if you think about like how that like the virtual machine world has evolved, like you have all these, like Linux is like, obviously the most common, operating system, but there's all these different distributions that are like, have different like trade-offs, etc. And so there's like this really long tail of different Linux distributions that like people use. And so I think that you could see a similar thing kind of emerging with execution layers in modular blockchains, where they follow one kind of common standard, but then there's like customizations and different sort of like, they branch out into like this family of different things.
And the best analogy is like there's a billion websites, right? But there's one Google, there's one Amazon. It's the website that have the best underlying infrastructure, the best partnerships, the best distribution that win. Similarly with like blockchains, whether it's a layer 1, layer 2, layer 3, layer 500, it's going to be the blockchain that can get the most partnerships, get the most users, and then whatever underlying infrastructure that allows them to accomplish that job the best wins. So whether it's Ethereum, whether it's any other settlement layer, with other DA layers, execution layers, it's gonna be a billion blockchains, sure, but there's gonna be 3 ones that actually get users.
Yeah, I think we use the same analogy here at Aptos. Like thinking about blockchains is very similar to cloud. There's several major cloud providers. It drops off after number 4 or 5 pretty rapidly, and that's the expectation we have. And we think that we're building out the right execution environment, the right consensus protocol, the right fully integrated stack that is going to support a huge chunk, if not all, the use cases out there. But again, very respectful of others that are trying different approaches in the space. And ultimately, though, I think we all agree that we'll see consolidation to a small number of technology stacks in the future that ultimately serve the most use cases, as Rushi mentioned.
Absolutely. Well, I'm all for experimentation, and I think maximalism doesn't serve you well. And I think we're in this incredible renaissance of let's try all the different variations and see what sticks. And ultimately, we're so early. We have like, we're all, it's a speck of dust, and we haven't even reached any sort of mainstream adoption. So I think this is a uniquely in that, like, it's a requirement to get there. So great work from all you guys. Really exciting. I guess any parting thoughts, things that you're excited about, you're building, challenges, or stuff that you want to call out before we wrap it up?
I like what you said, that we're so early. I agree. I think we're so early on so many different dimensions, and one being just the actual infrastructure. Like when I first got into crypto in 2017, I thought, wow, I'm so late. Like it feels like everything is already done. And like, here we are like 6 years later. And I actually now feel like we're still extremely early, and there's so much more innovation and experimentation to be done. And we're also early from an adoption standpoint. Like very few people actually use blockchains today. There's very little value that are like sort of transacted on blockchains today compared to like, the actual like scale of the global economy. And so I think, we're just a speck of dust. So I'm excited for hopefully in the next 6 to 10 years, like we'll actually get there.
Yeah, I think for me, it's like on Twitter, I see like Ethereum already won or the EVM already won. And the question I ask is like, what did you win? Like, you got the 10 users, you got like 4 people knowing about you. Like, is that what your definition of win is? So I think people are finally recognizing like network effects, especially in crypto, are very small. And all it takes is like one Kickstart team, one killer use case, one app that gets more than 10 users to really take away the network effects. And then EVM and Ethereum is not winning anymore.
Completely agree with those points. I love the fact that we're early. I love the fact that also the adoption is not there yet. I mean, I wanted that to change obviously over time, but I think the one thing I want us to leave us with is that the infrastructure is going to get ready really fast. It's not going to take a long time. It's actually pretty much here. That people can build reliably. People have the UX experience that is, if it's not here yet exactly, it's coming really, really soon. And our team is hyper focused on providing at least one clear path of making sure that there's a great fully integrated stack, a great user experience, low fees, and something that hopefully folks like Celestia and Movement, leverage in other networks. We love that. And we're going to push that future as quickly as we can.
That's great. Well, guys, amazing work. We'll obviously link to your Twitter handles and projects. So really exciting. I guess we ought to probably do a checkup in 6 months, because to your point, Avery, like if you weren't paying attention and you left the bear market, you now back, like you would be shocked at the state of infrastructure and how that is so quickly evolving. So great work, guys. I really appreciate you coming on and sharing your thoughts. I really enjoyed it.
Thank you, Santi.
Yeah.
Nice chatting with you, Avery and Rushi.
Thanks, guys.
Bye.
Bye.